Altair Inspire Cast enables designers to run filling and solidification simulations before finishing a mold design. Customer files are read natively or by using common CAD formats. Setting up the model requires just 5 simple steps before users can analyze the results. In the first step, we define the casting temperature and a predefined material from the library. Available materials can be used and viewed in different systems. In the next step, we define the direction of gravity as well as the position and size of ingates for high-pressure die casting. Altair Inspire Cast is parasolid based. Geometry can be imported from CAD systems and edited. For fundamental findings through the first run, we skip the ingate system, overflows, and cooling. A simplified tool is created, material and temperature assigned. In the last step, we define the gating speed. Among other result types, we've got the temperature, last air, filling time, or mold degradation. By visualizing the material flow, the position for overflows can be found. Looking at the solidification enables locating porosities and overheated areas in the cavity, as well as reviewing the heat transmission in the mold. To construct the mold or prepare production, the model has to be completed and as detailed as possible. The ingate system is imported from CAD. Overflows and cooling lines are created inside Altair Inspire Cast. A representative geometry of the mold is edited and cooling lines are sketched. Before defining the last parameters, the medium and temperature of each cooling line is defined. The velocities for the first and second phase are defined. The location where to switch can be defined manually. A high-resolving result is available, which enables a detailed examination of the casting quality. With Altair Inspire Cast, we can quickly detect and prevent casting defects, thereby reducing development time and cost.